Okay, I did number 21 on section 3.3, and this is the problem right here. And the first thing you have to do is find the critical numbers, and you do that by first finding the derivative. So f prime of x equals 6x squared plus 6x minus 12. And then you set that derivative equal to 0. And then you just factor to solve for the x values, and those would be your critical points. So you get critical points are x equals -2 and +1. And then the next thing you have to do is find where the function is increasing or decreasing. And you can do that by first you draw a number line and you substitute values from each of these three intervals, and you see if the first derivative is positive or negative. So the first one you can substitute f of -3, and if you substitute -3 into this derivative right here, you can see that -3 plus 2 is negative, and also it's a negative number, so it's positive. And for this interval, you can substitute -1, and if you substitute -1, it would be a positive times a negative, or a negative times a positive, and it will be a negative. And then the last one is you can substitute f of 2. There should be primes over here. F prime of 2, and you can see it will be a positive times a positive. So it's positive. So you can just label your chart. And the way you can tell if it's increasing or decreasing, if wherever the first derivative is positive, that means the function is increasing. So it's increasing on the intervals -infinity to -2 and 1 to infinity. And wherever it's negative, that means it's decreasing. So it's decreasing on the interval -2 to 1. And you have to write out a sentence for each of these increasing and decreasing. So I chose to do the decreasing. This is one example. So you would write the function is decreasing on the interval, and you state the interval, -2 to 1, because f prime of x is less than 0. And if it was positive, you would say increasing the interval, and f prime of x is greater than 0. And the next thing you have to do is find the first derivative, or you apply the first derivative test to find the relative max and the min. And you do this by substituting the critical numbers into the original function. So I'm just going to rewrite the function again. And then if you substitute f of -2, you would get -16 plus 3 times 4 is 12, minus 12 times -2 is minus -24, and the answer would equal to 20. So the relative max is -2 and 20, and you would know it's the maximum because you can see that the first derivative is changing from positive to negative at that point. So you can visualize it saying this is a max. You can see its first derivative is positive here and it's negative here. For the minimum, you can substitute the f of 1. And if you plug that in, it'd be 2 plus 3 is 5 minus 12 equals -7. So the minimum is 1, -7. And you can know this because the derivative changes from negative to positive at that point. So you can visualize it as this would be the minimum, so it's negative and then it's positive. And the last step you do is and then you would also have to write out for this one, and then for this one I just wrote for the maximum, the sentence would be the function has a relative maximum. You state the point because the first derivative changes from positive to negative at that point. And if it was minimum, you say negative to positive at that point. The last thing you have to do is graph. So I just plug this into Wolfram Alpha. And you can tell the critical numbers are over here because the derivative is 0. And over here because the derivative is 0. And then the function is increasing on these intervals, and it's decreasing, and then it's increasing again as a max and min at -220 and 1, -7.